Hello and welcome to the McHale Report podcast. My name is John McHale, Group Editorial Director for Military Embedded Systems and host for today's event. My guest today is Dan Diesz, Vice President of Design Technology with Rochester Electronics. This isn't the first time we've sat down together, but we're going to kind of update what's going on in the military aftermarket world, talk about component recreation, and onshoring of semiconductor manufacturing, counterfeit parts, MOSA, and much more. So Dan, to get started, I know you well, but the audience might not. Can you please provide a brief description of your responsibility within Rochester and a description of the company?
Sure. And first of all, thanks, John, for having me on. I appreciate it. Rochester Electronics is an authorized aftermarket manufacturer. So what does that mean? That means that not only do we have warehouses full of finished goods, about half of which are still active, by the way, and then we do manufacturing, and we do that from die wafer bank, where we have several billion devices under stock, and then my group does new silicon design and manufacturing for replicating original devices. So a very broad swath of what Rochester does, but really we're trying to extend the life of semiconductor products beyond when the original manufacturer wanted to, and do it in a fully authorized, above board, with their knowledge, authorization, and all that.
You know, you say billions, and I remember when I visited your facility years ago up in Newburyport, Massachusetts. I got a kick out of it because of all the warehouses and all the boxes. It kept making me think of Indiana Jones, where they stuck the Lost Ark. So if you guys have that, that would be pretty cool.
Several warehouses now. It's building 18, which is the big one, and then building 14, and then a free trade zone up in New Hampshire now. We have a whole nother, what we call building 20 in the free trade zone. We have a whole nother warehouse up there in New Hampshire for that as well.
Oh, you have grown since last time I was there. So the Defense Department is looking to embrace more commercial technology and innovation. Many of our audience know this, which means they will have to manage the shorter life cycles that come with commercial innovation and get creative with obsolescence management. But what is the cause of obsolescence management, and how preventable is it? Like, you're an obsolescence physician. How do we fix this?
Yeah, so I what I try to do now is really educate people on the four major reasons for product obsolescence, because just saying a product is obsolete really doesn't give the sustainment engineering people enough data. You get a product discontinuation notice, and first of all, you're 6 months behind learning that event's going to happen. But I can go into that in some other discussion. But there are four major reasons for product obsolescence, and there's probably more, but one is silicon obsolescence. That's the one everyone thinks of. Fab process went away. We can't make that product anymore, and so forth. But nowadays, really overcoming silicon obsolescence is package obsolescence. And so if your package is going obsolete, that's another way to look at it. Then there's also tester platform obsolescence. When you think about some of these complex products, they may have tens of man years invested in testing. The test program itself, the complexity of 1 million lines of code to test a complex processor. And then lastly is just revenue targets not being met. And so if you really dissect obsolescence a bit and start to dig into why those things happen, I mean, your next trip to Newburyport, you can see Rochester's been investing in the package obsolescence end of it. My design group has been in place since 2008, where we try to mitigate some of the silicon obsolescence part of it, but the package obsolescence part of it is a heavy lift. There's a lot going on in that space right now.
So you kind of talked about this at the beginning, your opening sentence, introduced, but where does Rochester Electronics, as an aftermarket supplier of mission critical military components, fit into DoD sustainment planning? What role do you guys play? I think maybe I should make that multiple roles, because
yeah, that's true. It is multiple roles. It sure that you can talk about the supply chain people saying, hey, do you have this? We got an unexpected order on something. Do you have it as a finished good? And that's a big part of our business, is the warehousing of product and the storage of product, and being able to do it that way. But if you really want to be proactive, you're really sharing the bill of materials with us so that we can actually see where you're headed and invest to meet you there. Where if people hold their product list back and they say, I'll tell you when I've got a problem, they're guaranteed to just be tactical and kind of trying to reverse out of the ditch they're in. And what we try to do with our customer partners is really get into what are your key products, what processors, ASICs, FPGAs, memory products did you choose, and are you strategically aligned with where we are with the semiconductor companies? Because that's our most important partners are the semiconductor companies directly. We're partnering with them to try to extend the life of products beyond when their business plan says that they should. And so the more input we can get from these customers, the more we're going to drive toward a strategic investment that makes sense and aligns with the market. But if they don't tell us, then we don't know, and then they're coming in tactical later.
So what's the average time from when a product's released by a semiconductor manufacturer before you guys become involved? How long is it out there? 18 months, 2 years?
Good question. No, it think about long-term system design, and we'll kind of we'll shoot all over the place here a little bit, but long-term system design, meaning 20, 30, 40-year design. That's really what markets do that. And then when you start talking about what markets do that, then what semiconductor companies support that?
Yeah, look at it the other way.
You got to, yes, exactly. You got to come at it the other way around, because you say, okay, it's commercial avionics, it's medical, it's industrial control, of course it's military and aerospace, but there's other, and automotive. And so there's other markets who are designing for 20 plus years, not just military and aerospace. And frankly, those markets garner mind share of the semiconductor companies more often than military. Military doesn't garner mind share most of the time. And so if they can align with that, and then think about the semiconductor companies, the one that's in the news, the biggest semiconductor company in the world by market cap right now is NVIDIA, right? They are not there. Yeah. We're not dealing with their products. They're not in our markets, and it's very clearly a mismatch. And if somebody's choosing to go down and incorporate an NVIDIA GPU and a display, oops, what are you thinking? Because that's not their market at all. Where if you look at somebody like Texas Instruments, Analog Devices, they're very, very clearly long-term system market. NXP, Infineon, ST. These people are serious about automotive. They're serious about long-term availability, and you can just sense that they're different, and than the semiconductor companies that are just in it for AI and we'll store products for you, but we're not going to really keep it active. It's just a different approach altogether. So I would say we try to get in and advise our customers, those that want to ask and listen. We'll advise them, please align this way, go down this way, because that's how we're aligned with the semiconductor companies to provide product back to these customers who need it for the long term.
One of the things you guys do is product recreation. So how do you recreate a product?
Yeah. Good question.
You have your own fab to do this.
No, we
right?
don't. No, okay. We don't. No. We are fabless. But the trick is, first of all, with product recreation, it's always most of the time we can't do it. I'll just start out saying that most of the time we cannot port a product from one fab process to another. It's got to be predominantly digital and not RF, for example. You're not going to port an RF product. You're not going to port a product that is, I tell my sales teams all the time, I say, if the data sheet has a whole bunch of graphs and lines in it, chances are that data sheet was created after the product was fabricated, not before. And the data sheet's created after the product was fabricated, that means it's tied to the fab process on which it was made. You're not going to pick it up and move it to another fab process and it be the same. Whereas digital products, yes, unless they have embedded flash. And when you think about flash becomes pretty picky. It's unique to the fab process on which it was qualified. But if you go back in time and you start thinking about 5-volt flash, 3.3-volt flash, those were never foundry processes. Nobody ever sold a 5-volt flash that was made in a foundry. It was always an internal fab process. So internal fab processes now are not available as foundry processes. You just can't do it. So if you take a look at all the old 5-volt and 3.3-volt stuff that the military guys still use plenty, if they used flash, they used a proprietary internal fab process to do it. And it's just not going to pick up and move somewhere else. Yes, pushed into a corner, said, you have no choice, but your life depends on redesigning this thing. Sure, we can get all kinds of creative with on-die voltage regulators and all kinds of crazy stuff, but nobody wants to pay what that takes to do it. And so that's the trade-off there. So product replication for us is really predominantly custom silicon designs, processors. We have a fantastic relationship with TI on their old 5-volt DSP products, where they actually provided us the physical design, GDS2, the source SPICE models, the test programs, and said, knock yourselves out. Don't consume our engineering and go. And we've gone off now and on a couple designs, and we're off on one of them. We've already done it, and the second one we're working on right now.
How old is that product? How long is that?
It was in the 90s.
That's what I thought. I remember covering DSP back then. Now PowerPC took over, so nobody really talks about DSP chips anymore.
No, they don't, right? Because you look at everybody that was part of DSP, and they're all kind of bailing out. Yeah. Because now it's done in an FPGA or it's done in software on a GPU, whatever. But lots of these things got designed in, and they're very, very, very specific. The trick to really, John, what customers come to us and they want to replicate is where it's a high barrier to change business. Usually, like in commercial avionics, it's DO-254 that stops it. With automotive, it's IATF that stops it, where that change is very regulated. And if we physically clone a part, and then prove it with data that it is cloned, that's high value to our customers that they don't have to change.
They don't have to recertify under DO-254 then.
No, it's a minor change. So what we can do
cost
is
savings,
yes, that's big cost savings. Exactly right. So under DO-254, when we physically replicate a device and provide all the data we provide, that flips into a minor change as defined by, there's a subsection in the DO-254 standard written by Boeing that's called a minor change as a result. Now, if you pick up an FPGA product, you did an FPGA design, you target your RTL to an FPGA, and then you turn around and you move it to another FPGA, oops, that's not a minor change anymore. That's a technology change. And that can be completely different, especially if you don't keep the same package and all that. Where we're keeping the same package, the same die size, the same voltage, drop in, and then we provide all the data that proves we did it. So product replication, that's like a 18-month journey. It really is from start to end. A prototype's at about 12 months. But when a customer doesn't have to provide engineering to do it, we're doing that. And then they don't have to touch software, and it's a minor change on their end. That's how we've grown from 5 people in 2008 to a little over 20 now in 2026. So, in 2 locations, 2 design centers. So, it's in demand, which is nice.
one of the things I find fast about aftermarkets by covering this defense industry for 30 years is some technologies never go away in military. I mean, 1553 VME bus are still being designed
Oh
into
yeah.
programs. But then I look at what some of the chips that you recreate that you still support, they go back to the 1970s when I was a kid and still being
Oh yeah.
used. So what are the common misconceptions that people have about aftermarket? Because I don't think everybody understands what it is. And what do you
Yeah,
hear?
no, I think people believe that first of all that Rochester Electronics might just be an old warehouse of parts, and I think they underestimate what that is until they come see us up there. They don't realize, holy cow, this is a massive stateside assembly operation with REL and Qual and all that, in addition to the design groups that we got in place. And I think when they see that the scope of the investment that we've made, I think they realize, okay, now we kind of get it. Now we understand that they've really invested in assembly and test and die wafer storage, and they're trying to move with us as technology changes. Like now we can do BGA assembly. You go back 2 or 3 years, we couldn't do that, and now my group is very comfortable doing custom BGA substrate designs. We weren't comfortable doing that. Just it's a in motion constant thing where I think people think aftermarket. They're thinking, oh, they might pull parts off of boards. They might, it not fully authorized and really original silicon. And we have 2-inch wafers in house. 2-inch. That's from the early 70s, even before Rochester became a company, because it was under proper storage at the original semiconductor company first before they transferred it to us. And so we got 2-inch wafer, 4-inch wafer, 5-inch wafer, going all the way up to 12-inch wafer under storage. And so I think when people see the scope of what it is, then they kind of realize a little more about what it's trying to be. But in reality, we're going to constantly grow because obsolescence is going to keep happening even more rapidly. And we've got to come up with solutions for our customers to keep systems going. These systems are not going to shorten lifetime. You can't. Nobody wants to pay $50,000, $60,000 for a new car, and 5 years down the road say, "Oh, sorry, you can't get these modules anymore for your car." Everybody wants that thing to be there for as long as they want to own the car. The same is true for a tractor from Caterpillar or John Deere. Nobody wants to make that kind of investment and then 20 years later it's gone.
Nothing runs like a deer, so it's got to run for a long time, right? That's their motto.
Yeah, and Caterpillar as well.
Yeah.
Shout out to the guys at Cat. They're trying to do, both of those companies are really trying to make sure that things live a very, very long time, and they've got unique problems as a result. Engine control units is a very tightly regulated thing. You think about what drives obsolescence for those guys, and there's some really tough challenges for them to overcome. So I think mostly aftermarket it should be viewed as your sustainment partner more than the guy we call when we can't get it, we can't find it on with my regular distributor.
Yeah.
That's how we would like to be viewed, as your sustainment partner more than a part number call. That doesn't really that won't work for you as well.
It's a lot more sophisticated than that. Also from a sustainment,
Yeah, of course.
sustainment side.
Yeah.
So the Trump administration is looking to double the DoD budget for the next fiscal year. The Defense Department is also pushing for more new systems and technology. Does it increase R&D funding or defense funding? Does that mean less dollars for sustainment technology, like aftermarket
No.
solutions, or does it mean does aftermarket funding depend on different factors?
Different factors. Anytime somebody talks about new money coming in, just like let's look at the CHIP Act as an example. The CHIP Act was 50 some odd $billion. And if you take a look at the top 3 or 4 or 5, it was really pretty obvious, right? It was Intel, it was Amkor, it was TSMC, it was Samsung, and Global Foundries, and it kind of drops off after that. And the same thing would happen with new DoD money. What the big programs, Joint Strike Fighter, you can go down the list, and then some kind of shield program. All those are going to get the big money, and that's going to be R&D. That's going to be development. It's not going to be sustainment related. But at the same time, every program that ever existed still exists. That hasn't changed. So all the push to have the same stuff is still going to be there too. I think it's new money, new programs, but that doesn't mean the old programs go away. If anything,
sustainment's still there. You're not replacing them, you're enhancing
not
them.
replacing. Yeah. Right. In fact, you're adding to the future of what will need to be sustained.
Right. We're still sustaining the 50-year-old B-52, the bombers and stuff. So, yeah. The one thing we cover a lot is open architectures and the big push towards a modular open systems approach. There's a push toward open architectures. How does that impact, if at all, aftermarket component designs or aftermarket supplies?
I think in some ways it'll make it worse. It is
really okay.
Yes, I do, because now it's just statistics. It's just math. If you're managing your own bill of materials and you're looking at all the components, nothing is black boxed. On an open architecture, you're going to have black box items. But that black box item actually has 50 or 100 or 200 devices in it. It's not one item. It's 200 or 100 items. The statistics of obsolescence are such that they multiply together. So when you look at, you got two components with a 90% chance of obsolescence, that's an 81% chance. It starts multiplying together down that road. I don't think it gets easier. I think it gets harder, because now there's no insight by the OEM. The system OEM has no insight into the black box, and the black box is, hey, we can't get this, and this. If they even tell you that, they'll just say the box is no longer sustainable as is. I need to move you to another box. Now, can that work? Yes. But at some point, you got to be careful what processor architecture you choose, because that doesn't always migrate forward easily.
I would think there'd be some software challenges too.
Yeah, exactly. Yeah, that's what I'm saying. Yeah, at some point in time, you're going to hit that software wall where a simple performance upgrade of more memory, more speed doesn't exactly work for a COTS box, and you're going to be, then what? Yeah, well, okay, now I'm at the end. So I don't think it's going to get easier. I think it's going to get harder. I think there's going to be less visibility into those pieces. If the sustainment, or let's say the ability to upgrade, doesn't get easier with open architecture, then you're not making it easier. You're making it easier to come to market, but you're not making it easier to upgrade when you have sustainment. So it's kind of, if you drive that way towards an open architecture, you better simultaneously make it easy to swap later when there's an upgrade, because that's what's going to happen. You're going to be down the path with no visibility to the BOM on the inside of the COTS box, and you're going to have to go, okay, as long as it doesn't touch my software or minimal change to software, then I'll keep going that way. But there's got to be more flexibility going down that path to change.
Interesting. And whole interoperability as well is when you keep upgrading. And then you mentioned the black box, it has to be interoperable with whoever comes next. But they might not want to change the black box, but upgrade everything around it.
Yes,
right?
Yes. So how much backward compatibility are you going to force on the system that, or on the guys creating the boxes for you? PCI Express, as an example, is maybe N-1 compatible, N-2 compatible, but how deep are you going to force that compatibility chain on the guys doing the open architecture? Because that's going to become an issue. So anyway, I don't think there's going to be any lack of work in sustainment or what we do. I think it's going to be as big or bigger challenge going forward.
I think you'll stay busy. Yeah. I'm going to go backwards a little bit. You talked about the CHIPS Act. So how does the push toward a trusted supply chain, onshoring to semiconductor production, how does it impact your company or people like you?
Yeah, the CHIP Act itself didn't. I mentioned that the kind of top four or so companies that really got the bulk of the allocation of the money, and that was all for new silicon. That wasn't for sustainment silicon at all. It was only for new silicon or 2.5 and 3D assembly. So most of what got done there, we're like a lot of companies in the U.S., we're going to take advantage of the tax credits on R&D investment. You have to. There's no reason not to do that, but that's the extent of it. I don't see that it changed what we did. It made what we did. We could maybe do it a little quicker, but no, it didn't change the vector we're on. You think about it, the vector we're on is pretty clear to understand. The package obsolescence has overtaken a lot of the silicon obsolescence, and we got to be there with the right assembly types for the customers that drive a decent amount of our revenue. So it hasn't, the CHIP Act itself didn't change the path we're on. It might have accelerated it a tiny bit, but it really wasn't. It really wasn't aimed for sustainment or aftermarket manufacturing at all. It was really aimed toward, hey, how can we bring the latest and greatest to the U.S.? And so I didn't see it as an advantage for us. A lot of what we end up having to do is, in fact, if you take a look at what has happened subsequently, is right now that for ITAR fabrication for regular CMOS, 5-volt CMOS, 3.3 volt CMOS ITAR. If you take a look at what's available commercially that can handle ITAR, there's one place. That's it. And so that's not choice. It really isn't. Just... And so and they didn't really get sustainment money out of CHIP Act or anything. And so that's okay. The emphasis wasn't in any kind of legacy or sustainment at all. So yeah.
You say ITAR also makes me think of foreign military sales. So
yes,
they're going to be using older platforms, older equipment. We don't sell them the greatest stuff. We don't give them the latest stuff, our allies. But I would think, is that a steady business for what you guys do, especially in aviation?
Well, I'll say that interesting things have happened in the last year. That you've seen Canada announces they're not buying Joint Strike Fighters, they're buying the Gripen from Sweden.
Yeah.
And you take a look at the increase in military spending in Europe. The likes of Typhoon, the likes of other platforms are actually increasing.
Yes.
So from a Rochester Electronics perspective, we're seeing demand, but it's not demand for US-based systems there.
Interesting.
It's demand for European-based systems to continue to support their increased investment in more systems that they created over there.
Hence why I saw your big presence at DSEI last fall.
Yes, exactly.
Okay. So it was more about, my brain immediately went to foreign military sales for here, but no, they're all increasing their budgets to like 3-5%.
Correct.
So,
yes.
And they're going to spend more on that.
Yes, there's FMS. There's always FMS sales. Absolutely.
Right.
That's a constant with us. But I will say that the bigger lift, the bigger increase has been the increase in native EMEA systems that are kicking up, and they've got the same obsolescence challenges that is in the U.S. But they have a bit more urgency about their way right now to kick it up, and I think they are.
Interesting, and I'm going to keep an eye on that too, because we're seeing that as well from investment, the news stories, everything that we cover.
Mm-hmm.
But something I don't see as much of anymore, and you and I used to talk about this a lot over the decades, was counterfeit parts.
Yep.
And all the horror stories and the crazy ideas the government had, like using plant DNA to mark parts and all that stuff. So, how big a risk are counterfeits today? And have mitigation efforts that we talked about all those years ago, they succeeded in lowering the risk, or is it roughly the same?
Yeah, good question, because you don't hear much, right? You don't hear as much. I'll say in media or even in meetings being called, or certainly no congressional activity along this line anymore since Levin and all those guys were doing their thing. I think in 2008 or so is when all that was pretty active. That was the realization point. I'll say, hasn't gone away. It hasn't. It isn't up on the problem list as big as other problems. But I'll say that we're bailing a customer out right now that bought parts that Intel used to manufacture, that we are licensed to manufacture, and we have ported the product. My group did, and they got themselves a bunch of parts that didn't work, and that still happens. And so it's very real. It's very out there. But what happened, you got to think about, okay, the NDAA and what language it had in there. The language it had in there actually incentivized the OEMs to not report, because if they reported, it would be a litany of what they'd have to do to write it off or excuse it away. And so they don't want that. And
so it's underreported. That could be part of it.
Oh yeah.
And when they report, I can't remember when they report. Is that public information?
I don't think the big OEMs are underreporting. I think they also got a heck of a lot better. If you take a look at the Lockheeds, the Northrops, the Raytheons, and so forth, I think they're a heck of a lot smarter than they were 10, 15 years ago about counterfeit. And they've put things in place to really mitigate that a lot. The biggest ones. It's always when you get down to subcon of a subcon that it's still alive and well. And that's where the issue is still alive and well. And this example I got of the Intel part that was counterfeit, it wasn't a military account. It was not a military system. It was a commercial system, but nonetheless, it was impactful. It was bad news for them. So, yeah, there is a couple Chinese companies out there that are actively selling some Intel part numbers and some TI part numbers, and and the TI part numbers are even still active with TI, and these guys are selling them, and nobody's doing anything about it. So I think what's happened is the semiconductor companies have gotten busy doing other things. They're not really paying attention to the counterfeit end of things. Their largest customers never got counterfeit to begin with because they're direct buy. They're only receiving direct from them, so they don't get counterfeits ever. And that's where the bulk of their money is. There's not so much counterfeit in the automotive area because they're getting direct. They're not going through distribution. They're not, aftermarket though. Aftermarket automotive, that's a whole nother thing. But the guys like Denso and Bosch and Continental, they're buying direct. They're going direct to the semiconductor companies, and they're getting their product direct. So they never see counterfeit, and they never worry about it. So I would say that it's just gone quieter. But if you look at ERAI data, do you know the guys at ERAI?
I know who they are. Yeah.
Yeah, they are probably the best measure of counterfeit activity. It's not. You can't really go to the bank with it. It's more of a relative. How active is it? But I would say ERAI is the best measure of counterfeit activity, and it hasn't slowed down. I mean, let's take a look at one piece of the market right now that a lot of people realize, and that's DDR.
Okay.
DDR memory is incredible shortage right now.
Yes.
So what's going to happen? Yeah. Okay.
The counterfeiters are going to pop up like everywhere.
Well,
black market, something like that.
Well, yeah, and there's plenty of discarded product that with board pull DDR memory on it that's going to be pulled. And that's what's going to happen. And you could just tell the shortage is there, the 30-40% price increase as the big memory guys transition to HBM and they can't make enough HBM memory. Counterfeit DDR is going to be there, man. That's what's going to happen next is you can just see it coming.
So the old mess is still the same, buy from trusted suppliers. right?
Buy from fully authorized
Fully
suppliers.
authorized suppliers. Okay, correct.
Trusted's a little bit vague.
It's a
Fully
little
authorized, which is AS 6496.
okay.
That's the standard. If you can say you are AS 6496 compliant, that's good. That means all your product came direct, never left the authorized channel. Saying trusted is vague. Sorry. There's
Oh,
just
that's a good. I'm glad
there,
you did it. That's a really
there's
good way of
no
putting it. Yeah, too
standard
big.
associated with trusted. I trust my sister, but I sure as hell wouldn't buy semiconductor parts from her.
It's
She's
out there
trusted.
now. Now the world knows you
I
won't do
know. Sorry, June.
that.
But
But
that's
yeah,
but it's AS 6496 fully authorized.
okay.
Those are the key words. And if a company could say those words about the product they're selling to you, that's impactful. That's okay. Yep, got it. That means it never left the authorized channel. Brand new, always, no problem.
You'll pay more, but you won't get the counterfeit problem.
Correct.
So
Yeah, that's
it's
the
at the end of
idea.
the day.
Yep.
All right. So this, you touched on this a little earlier about you have stuff in storage going back to the early 70s. But what
Yeah.
is the oldest part that you still support and basically send off to a customer? Or what application area is that in? Is it industrial, avionics?
Yeah, so I love talking about this one because it kind of blows people away that this became a problem. But there was a company in France that wanted a 6800 processor from Motorola. Okay,
That's going way back.
6800. It was introduced in 1978. It was the first 8-bit from Motorola. And they had a real problem on their hands. They were doing power distribution throughout France, and the network, the geopolitical thing was France has invested in nuclear power. Neighboring countries not as much. They had power in France to sell. The power distribution network 6800 based switching works flawlessly, well understood, rigorous. They understand it, they can control it, In order to expand that, they needed the same thing. And so the 6800 became a product that we brought back to market. Now, we didn't just bring it back. We tried to read the tapes, the reel-to-reel tapes the data was on, and they were goo. They were unreadable.
Oh God, yeah.
But this design was hand schematic captured on a draft table on a size D piece of paper rolled up, and we had it from Motorola back in the day down to the revision letter of each transistor that changed.
Wow.
And we went back and replicated that whole thing. And remember, this was a design made of transistors, not registers and flip-flop and clocked elements. There's no such thing. Everything was discrete, separate, asynchronous, and we were able to repeat all of the behavior entirely. And you do that painfully with chip level spice analysis. You can't do it. There's no Verilog or VHDL or high level simulation or none of that. No. And none of the design tools today for chip designers work. None of it does, because it's not an edge triggered classic RTL type design. It's a completely asynchronous design with register elements that are made up of transistors in there. And we repeated the whole thing. And it all worked and flawlessly, and cross temperature voltage, the whole 9 yards. So yes, that's the oldest product, and we're still in a ceramic dip and in a plastic dip if somebody wants a plastic dip, but still in that dip packaging, because we inserted plastic dip packaging at Rochester and Newburyport to be able to continue to do the package. So not only brought the silicon back from the 70s, but the package back, and now the customer doesn't have to change anything and can continue going. So that one's the oldest. That one's
But
the
it's
oldest.
kind of cool. You sort of went back in time and recreated the process, recreated design. It makes me think of those living history museums. They try to live like they did
Oh
200
yeah.
years ago, and you're kind of doing
Yes.
that with technology. And you talked about the way the schematic and everything. It made me think of I got a tour of the Air Force Base at Cape Canaveral, and they take you to the old mission control back there, and
Yeah,
there's
yeah. I've
there's
seen that.
hand
Sure.
wired circuit boards
Oh yeah,
and
definitely.
the way things used to be done. It's pretty cool.
So
Um,
John, we have 3 full-time archivists in my group.
okay.
Okay, so 3 full-time archivist librarians who manage the data, not just from the design group here or from our semiconductor partners, but everything we generate as a company. Because we've got data all the way from the 70s and 80s that we needed to digitize, tag,
Hmm.
search, everything else because people also want traceability. We had traceability on paper from the 80s, as everybody did.
Right. Yeah.
And so we actually have the ability now to go back, digitally search
Oh, so you have
everything.
digitized all this archive of paper,
Yes, we
right? Yeah.
have. Yes,
Okay.
we
Yeah.
have, including thousands and thousands of design databases that were on reel-to-reel tapes. We've gone and read them all. We had a massive design archive from Freescale back
Yeah.
in the day. It was several thousand
Scale.
designs,
Yeah.
20,000 some odd designs from LSI Logic, where I worked for 20 years prior to coming here. 20,000, 30,000 designs from them, all on media. And now it's all on spinning, redundant, backed up disk drives. But we were able to read all that media and get it off, because any kind of media that you put design archives on, not good. You really need to keep it on spinning disk drives that are RAID up and everything
Not
else.
tape that turns to goo, as you said earlier. So
Exactly. And
yeah.
so I mean that's the extent to which Rochester's had to go to try to do all this stuff is just, I mean, it's not easy. It's not just, oh, bring the old stuff back. It's trivial. It is a combination of good archiving data, having people who understand what good data looks like, and then design data, a bunch of people that gray hair or no hair like me, and who can understand technology, but then also carry it forward. And so we've got that mix here that lets us do that. But we're clearly living. I joke with my team that we're in the late 90s right now with what we're doing. That's where we are.
Yes.
We haven't seen the turnover of the millennium yet. We haven't from a
Well,
technology perspective for most of what we do.
my last question is going to take you past Y2K.
Yeah, sure.
Let's get into the
Where are we
century.
going?
And so, looking forward though, so I know we're
Yeah,
talking about aftermarket. You're still
yeah.
living in the 90s. Is there a disruptive technology or innovation that you think will be a game changer for aftermarket suppliers? Or maybe not even that, maybe just a paradigm shift or a way you approach things. It could be a strategy. What's
We're we're
coming?
we're kind of adopting a little bit of that right now, where more and more of the silicon replication side of things, what we do to port designs from one fab to another, we're bringing that into design more. Recent investment in an actual component tester for the group. That's a good thing. That's going to kind of change our ability to characterize the original devices more effectively than what we were able to before. I think partnering, what's going to change for Rochester in general is tighter partnerships with the semiconductor companies, as more and more of them transition to fabless. It's going to be painful and awkward as they do that, and they're not they're not going to go entirely that. They're going to kind of do this mixed bag thing where they control some of the fab process stuff locally, and some they'll leverage what exists elsewhere. I think for Rochester, that's where our biggest focus is going to end up being, is partnering with the semiconductor companies more directly. And that will benefit the customers that are working with us and as a sustainment partner, because then we're a private company. We're able to move where we want to move without worrying about the quarterly side. That gives our customers opportunities to tell us where we should move to if they want to take advantage of that. if they hold back, say, no, I'm not going to tell you the bill of materials, like, okay, then you're not going to drive our future. That's it, right?
That makes sense. Yeah.
If they're willing to have us as a sustainment partner and share with us what they're trying to do and how they're trying to go forward, there's great assets in place at Rochester from an assembly and a design side to enable more options than anywhere else. And I think though, going forward, I think the partnership with the semiconductor companies is absolutely key. And I think that's where we're investing and partnering up. We just partnered with NXP on some of the oak processors that were, very key to some of our long-term system companies. That's an example, securing product before it even goes obsolete, but working with the semiconductor companies as they transition to obsolete on products we know our biggest customers still want. And so it's twofold, right? The companies, our partners, our customers have to tell us and trust in us that we're not going off wherever they don't want their data to be. But then the semiconductor companies willing to work with us too and enable that market so that they don't have to continue to support that market. But I think biggest change for Rochester is probably going to be in that space. It's going to be heading down that road, and it's a question of how many customers will come with us and drive us in the direction they want us to go.
Yeah, and like so basically having closer partnerships, making sustainment a strategy. In other words, aftermarket can't be an afterthought. You got to have this plan from not just from the semiconductor suppliers and also from the end users is kind of what you're saying.
Right. And John, I tell this to any group that'll let me speak for a while, is it when you get a product discontinuation notice, that has been in the cooker for more than 6 months. If you really play the timeline back, by the time you get it as an OEM, that thing has already been around for 6 months. Even if you just got it direct from the semiconductor company, it's been around inside the semiconductor company for 6 months.
So you're starting 6 months behind from the moment you get the notice.
Boom. And with fewer options because they've already baked it into their quarterly plan. They've already decided what they're going to do. And, can't you run some more? Years 6 months after that decision was painfully already made, and internal sausage making you don't get to see, arguing and so forth, that already happened and got settled. And that's how the PDN came out. And so I would, I'd love to pass the message, especially for the military market. By the time you're seeing a PDN, it's already been around for 6 months. Even if you just got it direct from the semiconductor company, just realize you're way down the road. The closer you can partner with an authorized aftermarket manufacturer for sustainment, a sustainment partner, the better off you're going to be, because you're not going to have that insight as to what's coming if you don't. You're just going to get the PDN.
Excellent. I think that's the perfect way to end the broadcast. So thank you very much, Dan. I always learn a lot talking to you. It's always fun. It's a great update on everything that you guys are doing and what's going on in the industry. And I want to thank all of you for listening today's McHale Report podcast, and look forward to seeing you on future broadcasts on militaryembedded.com.